Hi everyone, thanks for tuning into this Black Hat briefing. My name is Colin Estep, and I'm a senior security researcher at Netskope Threat Labs. Today I'm going to be talking about permission mining in GCP. So first I want to go through a concept I'm calling IAM exposure, which is the risk related to the identity and access management in our cloud environments. Then I'm going to go into a little bit of detail about how identity and access management works in GCP specifically, since our project is related to GCP. Then I'm going to present a real example that we found in a production GCP environment and walk you through how we found that example by showing you our permission mining solution, which is a project that we're going to be releasing to the open source community along with this talk. Lastly, I'll be going through some results that we produced from our solution, remediation steps that we've seen, and future enhancements for the project. Data exposure for cloud environments has been in the news quite a bit. I think we've all seen these headlines that talk about some kind of a data breach or a data leak from a storage bucket. We don't see the same amount of coverage in the media about IAM exposure, but it's an important topic that I think deserves consideration from any organization that might be using the cloud. So what do I mean by IAM exposure? Mainly, it's the risk associated with each user in your environment. If you knew what each of your users were capable of, then this would be an easy thing to evaluate. Unfortunately, I think most organizations are not able to answer that question. And we have seen incidents related to this happening in the wild. The most egregious example happened to a company named CodeSpaces. They ran their business from AWS, and an attacker was able to gain access to the environment. The attacker demanded a ransom from the company, and instead of giving in, CodeSpaces attempted to evict the attacker. They did not have a great insight into how strong of a foothold the attacker had, so their attempts were unsuccessful. And unfortunately, the attacker ended up deleting all of their data and their resources. So it got to a point where CodeSpaces couldn't recover and had to go out of business. Even if you're confident that an attack like this would not happen to that extent within your organization, it's extremely important to monitor and audit the risk your users pose. I think we all want to be able to answer some simple questions like, what can all of my users do? And what is the likelihood that any compromised credential could result in administrator level access to my environment? As cloud customers, it's our responsibility to figure out what kind of permissions to grant to each user. This is part of the shared responsibility model that we adopt when we become a cloud customer. So unfortunately, there's some factors that lead to us not being able to do this successfully every time. Some examples may be, hey, there's a project that really needs to get off the ground quick, and we're under a time crunch to provision the right privileges so that there's no friction there. So we may provision too many privileges in advance and think, oh, we'll come back and tune it later, but later never comes. Also, we may have some confusion about the capability that we're granting when we provision these permissions. I borrowed this diagram on the slide from AWS's documentation, and as you can tell from looking at this diagram, determining whether or not something will be allowed isn't always a simple process. So it's easy to get confused. And even if we are able to provision our permissions successfully the first time around and in a way that we're confident, it's difficult to audit indirect permissions or the implication of these permissions at scale. Since cloud environments are really dynamic, the implications can change over time. So now that I've given you a brief overview of the problem, let's talk a little bit more about IAM and GCP specifically. There's 4 different identity types in GCP, which are called members. Users and groups are pretty straightforward. It's similar to any other system you might deal with. A domain is related to what you find in G Suite, where you set up, say, netscope.com, and then all of your users have a netscope.com email address. So if you're using G Suite and then you want to give everyone in GCP a baseline permission, you can grant that to the domain. And then lastly, service accounts are what you use if you want to provide programmatic access to an app or a resource. Since all these are different, you might think that you have to do something differently for each one, but actually the permissions are assigned to them in the same way. Now let's go through some terminology, especially around how these permissions are assigned. So in GCP, they call a permission basically allowing a specific API call. So in this diagram on the slide, I'm showing an example of some permissions, and you'll see compute instance delete, compute instances get, and some other ones. These are actual API calls that are being allowed, but we don't want to go one by one and assign individual API calls to a user. So instead, we use a role, and a role is just a collection of these permissions, but that's what we need in order to be able to assign the permissions to a particular member. When we end up assigning permissions to a member, that's called a binding. So that's the relationship between a role and a member. And a collection of bindings is called an IAM policy in GCP. So there's also different types of roles that we're going to be referring to throughout this talk. The first one is called a basic role, and these roles are prepackaged in every GCP environment. However, Google recommends that you don't use them unless you really know how they work. And that's because they're very permissive, they're very broad, and so they could give a member too many privileges if you don't understand them well. The second type of role is called predefined roles, and these are also provided by Google out of the box in every GCP environment, and they're more job-based. So the example I had in the previous slide was the role of compute instance admin. This is an example of one of the predefined roles that they come out with that's a little more granular than the basic roles. So they do recommend using predefined roles. And then lastly, if you're an advanced customer and you really understand how these permissions work and where you want them, you can create your own custom roles to give members. Another thing we need to understand is that there's a hierarchy in GCP. The top level item is called an organization. So this is similar to the concept in G Suite of a domain. So if I have netscope.com, that will be my organization. And then under that, I can create folders. And folders could represent anything from different geographies, different teams, or business units within your organization. And as shown here, folders can actually be embedded within other folders. So you can have quite a big sort of tree. Next, we have projects. And projects are used to group resources together. So as we see here in this example, you could have dev, test, and prod in different projects. And so that way there's a boundary between these things so that you don't have, production data in a dev environment, for example. And then last, we have the resource level, and these are individual virtual machines, buckets, databases, anything like that that you're going to be creating. And those always have to exist in a project. So now that we've covered both the IAM structure and then the hierarchy in GCP, let's put these two things together. So this slide shows a diagram. On the left side, we see the IAM policy, and on the right side, we see the hierarchy in GCP. And what we're trying to show here is the relationship between the two. And what this is showing is that you can basically assign permissions at any level in the hierarchy within GCP. So I could assign a user permissions at the organization level, but I have to know that those permissions are going to be inherited all the way through the organization. So any folder that gets created, any project, and any resource in the entire environment will inherit those permissions from the organization. There's no inherent way within IAM and GCP to deny access that's already been granted. So you have to think about this and plan ahead when you're provisioning your permissions in a GCP environment so that you don't get caught up in an unexpected scenario of having a top level entity be able to operate on resources you don't want them to have access to. So now that we've covered some of those concepts at a high level, let's dive a little bit deeper into service accounts. The reason why I'm going to talk about that is that this is directly applicable to our project, and they're kind of unique in GCP because they're both identities and resources. And since they're resources, they must be created in a project in GCP just like any other resource. So here's an example where we have a project that has several service accounts in it. And then we have a user that we want to give access to be able to use a service account. Now, what this means is that the user will be able to actually activate that service account, which means the user will be able to assume the identity of the service account and be able to use its permissions to conduct some API calls. So here I'm showing the IAM binding at just one service account. So this red box is just telling us that, hey, he can't see or activate any other service account in the project. It's just this one. However, if I put an IAM binding for the user at the project level, now that user can enumerate and activate any service account in that project. So let's go through a real example in GCP to make this even more concrete. So here I'm showing a GCP environment, and this is a real example in a production environment. So I mentioned folders earlier, but you don't really need to have folders if you don't want to. You can have an organization node, and then you could have a bunch of projects under the organization directly. So in this particular case, we had a project under the organization directly. And the project had some pretty normal stuff going on. It had compute engine instances, Kubernetes, and a BigQuery instance. And the admins decided to create a service account within this project, and then they went and created a binding. But that binding was what they call an owner role. This is a basic role provided by GCP. Again, this is not recommended unless you really understand what's happening here. And it was bound at the organization level. So this was at the highest level in the environment. So why is this a problem? Well, the owner role has full access to all resources, as we can see in the description. This is a screenshot I took from the GCP console. So when you look at the role in the console, you can see this, that it says it's got full access to all resources, and it's got over 3,400 API calls that it can make successfully. Now, these API calls include logging, creating users, changing permissions, destroying and adding resources. So it's basically a full admin. So next, in the same environment, we have a user come along who needs to be able to do a few things. They need to be able to create and delete some resources. They need to be able to query data, and they're going to be doing a wide variety of things in the project. So the administrators just decided to give this user the editor role at the project level. And again, the editor role is another basic role that is very broad. So from the GCP console, if we look at it, we can see over 3,100 permissions allowed by this role, and it has edit access to all resources. So that means that whatever level you apply this at, it will have edit access to any resource under that level. So this user has edit access to everything in the project, and that includes the service account resource that exists in the project. Since he has the editor role, he can actually go in and look at every single service account in the project and activate them. So now he has a route to escalate his privileges up from just being in that one project to the overall organization and have full administrator permissions throughout the entire environment. So why is this such a problem to track down? Well, a lot of people attending this talk or watching this talk might have their own tooling already that looks at GCP environments by making API calls. But if you don't have some sort of a custom tool that you created or you found, then looking in the console, you're not going to be able to tell this very easily. There's various different consoles to look in, and you need to sort of piece the things together on your own. So here I'm looking at the service account console in GCP, and I'm looking at this one service account that I created to sort of model what we found in the production environment. So this service account has that full ownership permissions at the organization level. And on the right side of the screenshot, I can see a bunch of things that have permissions over this service account that have been inherited down, from some point in the organization. But looking at the service account itself, I can't tell that this carries with it any sort of great risk, compared to any other service account I have in this project. So just looking at this, I kind of don't have a clue. I have to go back and look in the IAM console and see what permissions are assigned to this thing as an identity, and then sort of piece it together. So that's where our permission mining solution comes into play. We really want to make this easier to visualize. So what does our solution do? Basically, it's just making API calls to see what your current configuration is, and by doing this, you can actually use it to continually monitor the environment. So you could run our tool once a month, or you could run it once an hour, whatever you deem appropriate for your environment. Once it grabs all the data from these API calls, it actually uses a graph to find privilege escalation potential. And it provides you a report containing the direct and indirect permissions for every member in your environment. So this way, users of the tool can monitor and mitigate these risks in real time. So let's kind of walk through what it's doing. What is the tool really doing? First, it needs to take an inventory of the hierarchy in the particular environment it's running in, because every environment is different. There could be folders, there could be no folders, there could be 500 projects, or there could be one project. So first we go through and we take an inventory of the whole structure of the hierarchy and figure out where the folders are, where the projects are, and group the service accounts under the correct projects. Then what we do is we compile the direct bindings for every member. So what I'm showing here is an example of what we found in the production environment, where I'm modeling it in my test environment. So I have a member called CSTEP, and I gave him editor permissions at the project level. And within that project, I have a service account that's got some higher level permissions. Below this, I'm showing another member that has different permissions that does not imply any sort of way of impersonating a service account. But we want to compile all the direct permissions so that in our report, we get a full view of what's going on. So once we have all the direct permissions, that's when we can start to figure out who are our impersonators, meaning who are the members who are capable of impersonating a service account and doing something in our environment. And that really comes down to these 5 main roles. And I've grouped them here in order of most permissive with owner at the top, and then least permissive with service account user at the bottom. And you'll see the screenshot here from the console again, showing service account user with only 5 permissions assigned to it. Even though it only has these 5 permissions, it's very powerful because it enables whoever has this permission, whoever has this role assigned, can enumerate and impersonate any service accounts in their scope. So finally, once we have that information, we construct a graph. And we chose the graph data structure because it's really great for modeling entities and relationships, which is what this environment really is finding who has permissions and at what level. So what we start doing is laying out the impersonators and creating the bindings that give them some impersonation capability at the right position in the hierarchy. Since we have the hierarchy and we have an inventory of the service accounts, this will enable us to effectively traverse the graph and find out what the scope is for each member. So like I mentioned, once we have the graph constructed, we can find potential privilege escalation by traversing the graph. And this will tell us every service account that they have in their scope. And then we can compile the permissions assigned to those service accounts and say that this member actually has an indirect permission, or what we call an extended binding, to be able to do something else. So now that I described what we're doing in the solution, let's see, what does this kind of look like? So the results we get from the solution will include a report for every member. And I've made it sort of easy to look at for this presentation, but here you'll get an idea of what it's giving us. So here I'm showing an excerpt of a report for my user CSTEP, and it shows that he has direct bindings and their project bindings. And so I see the name of the project here called CIFSEC GCP Dev. And at that level, CSTEP has the role editor assigned to him. Then under that, I'm showing the extended bindings. So these are bindings that we recovered from service accounts that CSTEP can actually impersonate. And it's showing that within those extended bindings, there are some at the organization level. And I see the name of the organization node here called cifsec.com. And then I have an array of roles at that level. And the one highlighted in yellow is the owner role, which is our full admin permissions. So that's really important to be able to see that CSTEP, although we think he may only have permissions over one project, that's not really the case if he makes use of the service accounts in his scope. And here's what it would look like in a graph. The graph that I'm constructing in the project is not meant as a UI, but I thought it'd be useful to show it here. So just quickly, the legend for the graph: the blue node is our organization node. The green nodes are our members. Light pink is the project, and you'll see the project associated with the organization. And then the dark pink or more reddish nodes are the service accounts located within the project. And as you'll see here, I have my service account that I set up as the admin in the organization. It actually has two different nodes to represent one account, and that's because a service account is a resource and an identity. So in order to be able to traverse the graph effectively, I want to represent that state in both ways. So I can show the service account that's in scope under the project, and then I can show its binding at some level in the hierarchy. Next, I have the impersonator associated to the project. So again, I can see what he has the capability to do. And that's how we created our report. So what does this look like for real? Well, when we run the tool in a production environment, it can get pretty hairy. The graph here has over 500 projects, several hundred members, and so it's no wonder that this is really hard to keep track of. Unless you have a tool that's actively monitoring the situation, it's going to be hard for anyone to manually understand what every single user is capable of in the environment. So now that we've gone through what the tool produces, what's its value? Well, some of the remediation that we've seen happen as a result of this has been the following. Bringing service account bindings down the hierarchy is one way to deal with this. So you might look at the result and say, well, you know what? The service account needs to have owner permissions for whatever reason, but maybe we don't need it at the organization level. Maybe we should create a folder and put it there, and that'll limit the range here. Or we see that, hey, the service account doesn't need a basic role. We should really apply more granular permissions to limit its scope. And so people do that as well. And then lastly, sometimes you set up a new environment and you do some testing and you just set up some quick things. You put some permissions in place just to quickly evaluate something, but then you didn't go back and clean it up. And so in some cases, you don't need the binding at all, and you can just remove it. The idea is that we want to proactively reduce the risk in the environment without waiting for a compromise. We want to have a smart way to audit everything and view that risk and make smart decisions about where we're going to take that risk, whereas maybe we need to reduce friction, but the idea is that we need to have all the information available to make the right call. So our first version of the tool that's going to be open sourced, I think, is a good start, but there's definitely some things that could be added to it. So I just want to go through a few things that we could add to the project going forward. And just in case anybody's seen this talk and is interested in contributing, I just wanted to share this part because maybe you'd find it interesting and want to add. So the first thing that came to mind was the compute engine. So when you have compute engine instances running, you're going to want to allow, in most cases, you're going to want to allow your users to SSH into them and have shell access to be able to do what they need to do. In a lot of cases, there's going to be service accounts associated to these instances. And so even if your user doesn't have the permission to access a service account directly, this is a way that they could actually get into an instance and use their shell access to make API calls as that service account. So this is another path for privilege escalation that is not currently handled in our solution. Another one that's interesting are within Cloud Functions. What I'm showing here is another screenshot from the console, and this is a Cloud Functions developer role. It's only got 16 assigned permissions, but the idea of it is to allow someone to deploy and update code for a Cloud Function. For anyone who's not aware, a Cloud Function is similar to like a Lambda function in AWS, where you're just deploying code and letting the cloud platform run it for you, so you don't have to maintain a compute instance or something like that. So in this case of GCP, Cloud Functions by default use the App Engine default service account. And that App Engine default service account is in the second screenshot on this slide. And that shows that it's using the editor role, which is, again, that basic role that has over 3,100 permissions associated with it. So the point here is that you could have a user that has very granular permissions, but needs to be able to update Cloud Functions, and they could actually deploy code that would allow them to escalate their privileges and make changes in the environment that may have been unintended, because that App Engine service account has way more permissions associated with it. Then lastly, organization policies. These are separate from identity and access management in GCP, but they do have an effect on what people can do in the environment. So this is something I think we need to take into account. And despite the name, policies, organization policies, don't have to be associated at the organization level. They can be associated to projects. So here I'm showing a screenshot for a project, a test project that I have, and there are some service account related constraints. And these constraints, if they're enabled, can prevent people from creating their own service accounts or creating keys for service accounts that would allow them to impersonate them. So we should really take that into account as a mitigation if these policies are in place, because we don't see that at all in the IAM policies if these are turned on. So it's just another service that we'll have to check and take into account if we want to present some really accurate risk information in our reporting. So with that, I just want to say thank you for your time. If you found this helpful or interesting, please go visit our Netscope Threat Labs blog. We're always posting things there as we find them and things that we think the community should know about. I have my Twitter handle here, my LinkedIn. If you'd like to reach out and talk about this, I'm more than happy to do that. And then also here's our open source URL for the project that we're releasing along with the talk. It's called IaaS Permission Mining. and under it you'll see a GCP folder for the code related to this particular talk. So thank you again, and I hope to hear from people who are interested in participating. Thank you.